Okay, moving on with the second part of 7.6, the natural base. The formula for continuously compounded interest is P to the ERT. A is going to be your total amount, P is the principal, which is the amount that you would invest, and R is the annual interest rate, and T is your time and year. Basically, you have some money, you want to make more money, you can invest it. So say I have $100. I want to invest it. And I found a bank that will give me, a 2% interest rate per year. So I change that 2% into a decimal. And so that's the annual interest rate, annuals per year. But I'm going to go ahead and invest it for 5 years. Okay, so my principal was $100. I have a 2% interest rate, and I'm going to invest it for 5 years. So we need to figure out how much money we're going to have at the end. So I'm going to go ahead and do 0.02 times 5 and raise that to the E. Okay, E to the 0.1 is 1.105 and some change. So my final amount of money after 5 years would be $110.52. Not the best investment, but that's a basic example. Okay, what is the total amount for an investment of $500 invested at 5.25% for 40 years and compounded continuously? So I have my principal, erase that, E to the 0.0525 times 40, and let's do some math. So E to the 0.0525 times 40 calculates out to 8.17, multiply that by 500 and I get $4,083.08, a much better investment. Okay, you try this one. Okay, again, not the best investment. 3.5% for 8 years, you have a whole $132.31. You could probably do some odd jobs around the house and make that in a weekend. The half-life of a substance. We're getting into the last example here. Half-life, that's more of a scientific application. So half-life of a substance is the time it takes for half of the substance to break down or convert to another substance during the process of decay. We're talking about trash or just things that are decaying. Natural decay is modeled by the function below. Half-life is used to, I just think about environmental issues and things breaking down in landfills and how we would prefer for the things to break down much quicker, because then they're not just sitting in a landfill. So half-life, that would be an application for half-life. Let's look at this equation. N sub O is the initial amount, how much you start with at time equals 0. K is the decay constant. T is the time, and N of T is the amount remaining. In most of these applications, we have to solve for K. Let's try one. All right, polonium 239, this is our science application, example 4, has a half-life of 24,110 years. How long does it take for a 1 gram sample of this substance to decay to 0.1 grams? So like I said in the previous slide, we have to find the decay constant first. Something new here is N of T equals 1/2, because that's our half. Our final amount is going to be half of our original amount, and our original amount is 1. E to the negative K we don't know, and time equals 24,110. Okay, I don't know what to do with this, but I do know that the opposite of E to the power is natural log. So I'm going to take the log of both sides. Okay, this simplifies, this left side goes log of 2 to the negative 1. In the second one, the e's disappear and I have negative 24,110K. drop that negative in front. And we can actually do the math here. I'm going to grab my calculator and do negative natural log of 2, close my parentheses, and divide by negative 24,110. So that was negative log of 2 divided by negative 24,110. That equals k. So in this instance, k equals 2.87 times 10 to the negative 5. And we're going to use that in the next slide, so write it down. So now we have n of t equals n of o e to the negative 2. I didn't write it down. 2.87 times 10 to the negative 5th t. Okay, now we have to solve for t. So our final amount is going to be 0.1. That was in the problem. Our initial amount is 1. Okay, take the log of both sides. Natural log of 0.1, natural log of e to the mess up here. So natural log of 0.1 equals negative 2.87 times 10 to the negative 5th t. Grab my calculator again and do that division. Natural log of 0.1, close parentheses, divide by negative 2.87 times 10 to the negative 5th. And I have t equals 80,229 years. Hee-ha, crazy. Okay, we already did that. Go ahead and try this one on your own. Okay, I found k, so push pause and write this down and move on. Now I'm going to use the rest of the problem and solve for t. Okay, look through this. Notice I isolated the e on the right by dividing both sides by 650. I divided this by 650. And I solved for t. Okay, I believe that's all we have for today. Look through these examples, make sure you understand them before you come to class tomorrow. Thanks.